Can you see the screen?
Yes, we can.
Okay. So today we are going to continue on human cognition and understanding and interpretation. I would like to start with the human memory that plays a very important role in interfaces. We have three types of memory in our brains and sensory systems. The first one is the sensory memory. Second one is the short-term memory. Third one is the long-term memory. Sensory memory is the kind of buffer, usually directly connected to our sensors in our body. Short-term memory is a scratch pad kind of memory, a cache-like memory to store rapid information. And the knowledge, actually, the last one is the knowledge stays in the long-term memory. Information basically flows from one another, starting from the sensory memory through attention. You look at that, and then the information is transferred to short-term memory. If you pay attention, then you take that in your brain. You take that in your brain as short-term memory. Through the rehearsal, if you repeat, if you concentrate, if you focus enough, then it is transferred to long-term memory. So that is actually what we say learning. Learn or remember. Sometimes you remember, but you don't have the ability to fully understand. In that case, it is not learning, it is just remembering. So that's also long-term memory. So how these are playing important role in designing user interfaces, that's what we are going to discuss. First one is the sensory memory. Sensory memory is for hearing, for seeing, and touching, plus smelling, so you remember a feeling of touch, feeling of smell, a sound, for example, a song that you heard is processed, and before it gets processed, it is taken by the sensory memory to be taken to further stages. So our ears, eyes, skin all has and associated neural cells have storage capabilities in them, so that for a moment of time, for a very short amount of time, it is buffered. It is part of the perception process. Constantly, new information overrides the previous information, and when you pay attention, kulak kabartmak, when you pay attention, for example, for the hearing, there is a filtering going on. For example, if I am interested in, for example, Muhammad here, so I will concentrate on Muhammad, and the input coming from Muhammad or Türker or Rahmet Ali will be processed much more than others because I am paying attention. So attention direction has an effect on the sensory memory. For the eyes, it's basically through rotation of the gaze, rotation of the eyeball. Second one is maybe the most interesting one is the short-term memory. Short-term memory is like a cache. Analogy for the computers. It has very limited capacity. It's like 7 is the magic number. 7 pieces of information, rapid recall of information, rapid decay, you forget, very quickly, or in about a half a minute. In order to prevent that, you need to repeat. And rate of decay is influenced by amount of information being stored and attentional resources available for the rehearsal, such as if you are in a battle, having said that Russia is invading Ukraine, for example, if you are being invaded by other country, so your short-term memory capacity will be lower because you have additional attention demand. Something is happening, or interestingly, in the interfaces, if you have a customer in the shop, in the bank, in the government office. So if you have a person in front of you dealing with you and you are trying to use the computer, your short-term memory capacity is reduced because you also have to talk to the person, and you also have to talk to the person and make him or her happy. Therefore, it depends how much your attention is going into the interface. If your full attention is going into the interface, 7 is a good number. 7, it is not 7 bytes or 7 bits. It is said to be 7 pieces of information. It could be numbers, it could be letters. It depends how you remember it. It could be shapes, etc. Or combination of letters also. Small words are also one piece. Yeah, I have an example. For example, short-term memory is constantly used when we are operating things in our surrounding. For example, in the computer world, we look somewhere else, and do something. In the meantime, we combine the information that we gather from windows, several windows, process and enter another information to another window, or on the same window in another field. Therefore, you are constantly reading, processing, writing, reading, processing, writing. As you read, you need to remember it for a moment of time in order to process. Such as a bank teller asked your ID, or you gave the ID, he is going to, or she is going to look at the ID card and type the ID card by looking at it. How he is going to remember that number during that transfer is very important. This is your ID number, for example, or IBAN number. You are telling that because you have memorized it from the long-term memory, but as he or she hears it, he has to hold it and type it into computer. If he or she cannot hold it, he says 356, and then what was it? So multiple questions will come if he or she cannot remember it correctly. So it is usually difficult. For example, in the shops, they started tracking us without cards lately. In the earlier years, all grocery shops were distributing cards to track customers, like Migros card, Carrefour card, BİM card, A101 card, etc. But lately, they forget about cards and they started using virtual cards, and they ask your phone number to track you. However, you have to tell your phone number, and the person, the cashier, should get the phone number from you and type it in. If he or she cannot hold that phone number in the memory, then it will be impossible for that process to go. Multiple questions will be asked. Then he or she will ask 533 and then what? So multiple times you have to repeat your phone number. If your phone number is very different, such as 533 20 20 20, something like that, then it will be easier for him or her to remember without failing. So probably some things are easier to remember than others. That happens in license plates, that happens in names. Sometimes the name Ahmet Öztürk is easy to remember. Sometimes Vladimir is easy to remember. Sometimes Süleyman is easy to remember. It depends. If your grandfather's name is Süleyman, then you remember it that the guy name was Süleyman. But if you heard it for the first time, if you have no neighbor and no relative whose name is Süleyman, then it will be harder to remember for you for that particular word. So, for example, the words from different languages, and if the word has no meaning, then it will be more difficult to remember it. So, the first example was a bank teller examining your ID card and entering your ID number to the computer. So there is an information transfer, and during that transfer, a cache is used. So it is the short-term memory. And or the washing machine. In the washing machine, you look at the manual on the washing machine and you program. So in between, you keep what to do in your short-term memory, because 1 minute later you forget. And this is also important. There is an error, such as this file is not found. Please write another file. Give another file name. Give another username. Taking new username from the Hotmail, for example. That username is taken. Password is incorrect. You say OK, and the message goes away. You start trying again, but then You forget what was the previous message. You have to remember the previous message in order to continue for the next screen. Therefore, it's quite important to remember things from the previous screen. What can we do? The things we can do, the first thing is that try to minimize memorizing from previous screen to the next screen. That is basically requires redesigning Windows so that information that needs to be remembered will be shown on the next screen. If you show the same information in the next screen, such as previous tries, previous file name, which is not found on the next screen, then people will remember that that was not available, so try another one. They don't have to remember it. They don't have to remember the incorrect entry. Your mother says a telephone number, or your grandfather, and he or she says 5 43 646 7 342. Then it becomes very difficult for you to write them down because the pattern, the chunking, the pattern is very different than the pattern that you are used to. Normally, you expect something like 543 at the beginning, then 3 numbers again, 346, and then a pause, and then 7220, and 4 digits. So basically what you look is 533, 346, 7220. So if you write it down like this, you remember it for the transfer purposes, you remember it more easily. If I say this like 5 3 3 3 3 4 6 7 2 7 0, then you will say, what was it? You cannot store it in your short-term memory. Therefore, meaningful divisions are good. However, those divisions must be standardized in the population. If you get a division that is very different than the one you are used to, then you fail. So for national ID numbers, unfortunately, they didn't make a division. In the United States and in UK, they have divisions for the national ID numbers. So when you are saying your national ID number, it is like phone number with chunks. So it is easier to remember. And everybody shares that kind of division because government offices started dividing it in a certain way. Just like telephone companies are dividing phone numbers based on usually global standard came from United States. The last interesting example of short-term memory is you are dialing a bank voice interactive voice response menus, IVR, hotlines, and then you get a voice menu. If you want to do something, press 1. If you want to do another thing, 2. Another thing, press 3. Another thing, press 4. Press 5. Press 6. Press 8. So when it comes to press 9, you forget that what was the correct selection. Was it 2 or 3? You forget. basically, if you have too many selections, as the voice speaks on the phone through the 7, 8, 9, then you tend to forget 1, 2, 3, so the beginning part. Therefore, it is much better to use 3 or 4 selections, and then go another 3 or 4 selections, go another 3 or 4 selections, rather than having everything in one big menu, in the voice operated menu. You narrow down the selections so that people can remember and evaluate which one to select and progress further. So deep trees it is basically a tree structure. So deep trees are much better for less errors and for public interaction in the voice operated menus. However, if you are a professional, like if it's an internal phone system, then wider voice menus may function little bit faster for professional users, because as soon as you call, you have 9 options to push from 1 to 9, or people, the interface designer may ask, enter operation code. So operation code might be 2 digits. So if you are a dealer of a, for example, car parts brand, you can type numbers of the associated parts and parts divisions so that you are transferred immediately, rather than trying to listen what to do, because you are calling it all day. I mean, multiple times a day you are calling that number. So and you have a menu, for example, in the system, then that kind of wider selections are possible. But for the general public, it should be narrower and deep. Yeah, some of the examples. The difference is this is much better than writing it straight. So what can we do? The first one is reduce the amount of information to be stored. So try to eliminate from your interface that people should remember that fact. People should remember the information from the screen, from the interface. Try to minimize short-term memory remembering. Second, try to use chunking. This is one example. Chunk size is usually 3 letters, 2 letters, or meaningful is better, such as if you have a license plate like this, it is easy to remember because there are other associations. Usually, letters are easier to remember than numbers because they are more vocal in the brain. And we must separate letter chunks and number chunks from each other like this. So this is much difficult to remember than the one above, because letters and numbers are mixed. So that is different. That is difficult. Unless you are trying people not to remember. sometimes you want to do that, you can mix. Support using visual aids and hints, such as you are asking for phone numbers. So if you are asking for a phone number, make a space visible so that people will automatically forced to use that kind of chunking for the IBAN number, for the email, for example. You have for the username, you put an @ sign, so people will automatically think that your username is your email. If there is an external attention grabbing factors, try to reduce that. So if somebody is bombing you, stop bombing. And also, most of the information is distributed based on the importance, and the most important ones should be repeated in the next screen, such as where you are, what is your ID, what is the target ID, what is the case number, account number. If it is going to be remembered, if it is important, don't think that people have it automatically for the second time. Put it on the screen so that they will recognize it and they will use it. These measures and some other measures, of course, these are just examples, reduce the use of short-term memory, the load on the short-term memory. Therefore, interface is set to be easier to use. So if the interface is easier to use, usually it does not use short-term memory a lot. If the short-term memory use is required more, then our interface becomes harder to use. Any questions or comments? It is welcomed. My chat window is also open. Yeah, this is interesting. You go to the restaurant, and usually a guy comes, not girl. Guy asks, "Abi ne yersiniz?" Okay. You say, "Ne var?" He starts saying that Adana, Urfa, Beyti, Iskender, etc. So he speaks a lot. Then it is like a voice menu. You forget what was the second one he said. Or he doesn't tell all the menus. He basically tells what is available that day. So then you order. He listens or she listens. And usually does not take notes, most of the waiters. He remembers, maybe he repeats it. 3 İskender, 3 Adana, 2 tane Urfa değil mi abi? Etc. Then ortaya salata yaptırayım mı? Then içecekler. And Suddenly I ask, how do you remember all these things? So he smiles and our food comes back and sometimes incorrect. Usually correct. So they train themselves for a limited amount of limited set of items. They train themselves to hold that kind of information for a short amount of time. Short amount of time means they memorize from the desk, they memorize from the table, and then go to the kitchen and type it down to the computer system, the panel, or tell inside, whatever. In the more complicated scenarios, they take notes. They take notes, and the note is taken into kitchen because there might not be an automated system. So waiters are more comfortable with the automated systems because they don't have to go to kitchen. All they have to do is go back to the edge of the restaurant, and from the touch panel they enter the order. Sometimes they have a tablet or phone on their hand, so they can enter the orders as they are getting from you interactively. In that case, their short-term memory burden is reduced because they have that on their hands. So as she speaks the menu, you need to remember. Basically, the waiter asks for what to drink, what to eat, salads, desserts, separately. Because if he or she gives it as an Excel table, it will be very difficult for you to select one item. Think about it. One item is Iskender, the next item is künefe, and next item is Adana, next item is 7-Up, etc. So it must be grouped. In the menu, in the fast food, therefore, things are grouped. As you go through the fast food restaurant, you check the menu in the board and you observe menus one by one. Each of them has limited amount of items. In that case, since the magic number is 7, you can capture all those and process that in your short-term memory and make a decision. If you don't want anything from that part, you ignore that. You close that window and then move to the next one. Another processing. Then you say, okay, I like this. And then you close it. You check here, close it. So you check blocks one by one, like pages. And each page is containing not more than 7 or roughly 7, maybe 9, 10 elements. In that case, processing will become very successful. In the recent trend, unfortunately, fast food restaurants are placing LCD displays instead of menus. And unfortunately, they are rotating images and menu items as you stand by. And once you see something, it will be very difficult to remember if it changes. You wait for the same image to come back. It's kind of dangerous thing, but when carefully used, it may have advantages, such as not displaying too many different images on the LCD display, and repeating important information in most displays, etc. Unfortunately, again, that's not an energy efficient process. It gives a lot of additional cost to the fast food. So I'm against it. I like fixed menus, and those menus may not, may not change frequently. Big Mac is Big Mac for years, so I don't have to have it displayed on an LCD screen where the cost is transferred to me. If we learn things, like I said, Big Mac, how did I learn it? I learned it by going into fast food restaurants for years. So that is in my long-term memory, not short-term memory. If something that I don't know is in the memory, as soon as I read it, for example, Süleymaniye kebabı, which I don't know yet, then it will be processed in the short-term memory along with the ones from the long-term memory and to make decisions. So everything we know is stored in long-term memory by learning, reading, and training through experience, and it is slower, like hard drive. Not very slow, but slower than short-term memory. Long-term memory is not like a computer memory. It does not contain exact and complete information. New information is written onto old information. Some of you are you have taken neural network courses or deep learning or machine learning, whatever. Machine learning is kind of different, but neural network, when you concentrate on the neural network, there are weights and there are neurons, so the complete information may not be available on the neurons, but relatively some process can be done. The connections between neurons are modified when you are learning certain things, and that makes the knowledge. When new information comes, old information is modified. That's what we call training of the artificial intelligence, or non-artificial intelligence, which is our intelligence. Same way of training. So if new information is in parallel with the old information is strengthened in the model, in the neural network model. The weight of the neuron is increased. But if the new information is not aligned in the net, if the new information is not in the same direction with the old information, then weight of the neuron goes to 0, or maybe negative side. If it is in the negative side, that means other way is selected. So it depends, and that is what we call interference. If the old information is interfering with the new information, the performance is reduced, such as in the remotes, how do you switch channels? Up or down? When you press this arrow, do you have smaller channels on TV or bigger channels in numbers? What do you think? Some TVs have yeah,
It should be bigger channels,
but
but it doesn't make sense actually.
when you have screen menu and one of them is highlighted, when you press up, it goes up. When you press down, it goes down. But on some other interfaces, if you press up, it goes down. Usually, the mostly preferred trend is if you have on-screen menu available at that time, at a particular time, then up means smaller channels. If you don't have on-screen menu, up means increase. So selection between two meanings involves there. Up sometimes means upwards on screen. If you don't have on-screen menu, up means increase the channel number. But that contradicts in the interfaces sometimes. So most people will fail when they are switching from one television to another television because the other television has accepted different way of interacting with the channel numbers. Then until you get used to it, you fail. In the apartment buildings, this is your door, entry door. There are two buttons. One button is for bell, other button is for light. Right? Usually, the closer to door, the switch that is closer to door must be associated with the bell, doorbell. But some electricians who try to look nice, place them very close to each other. And sometimes electricians, during the installation time, they crisscross the cables. Sometimes distant one is bell, the closer one is light. In that case, you always make mistakes because old information is interfering with the new information. And it is very hard to learn it. You don't learn it because in other houses it is different. So it constantly gives you trouble. Same kind of problems happen in the interfaces as well, in the computer interfaces and systems as well. When we think about long-term memory, all people have different brains, and the organization of those brains are different because of the different stimulus during the development. As the child grows, the neurons are formed differently, and the weight of the neurons, weight of the connections will be different. And when a person gets a stimulus, like an image below, how it is processed depends on the person. So it changes from person to person. In order to understand that, that's what there is a keyword called mental model. Mental models are used to explain why did this guy hit the wrong key, because nobody wants to hit the wrong key. You hit the wrong key because you believe that it is correct. So the issue is we need to understand why the person is hitting the wrong input. If we can correct that, because he is or she is hitting the incorrect key based on the interface, based on the information taken from the interface, creates a model in the brain and then acts. So mental models try to explain our behavior. Therefore, how many of you see young lady here and old lady here on the left image? I think most of you can see both. Again,
I cannot see the young lady.
okay. Young lady's hair. Okay. So you process the information based on your previous experiences. That's why psychologists ask and show an probably not meaningful shape, a random shape, like an ink spot, and ask, what do you see there? What you see there is dependent on what you have learned in the past. So they try to understand your experiences and things that you have faced with in the past by having you interpreting a random image. Because interpretation of random image is based on how you train your brain in the past. Diyorlar ya bazen bulutlarda Atatürk resmi çıktı falan diye. Onun gibi. Okay. So long-term memory is interesting. Short-term memory is also interesting. And when we come back to interfaces, there are direct consequences. I think before going further, we may give a break. So let's give a break for 10 minutes.
Okay, see you in 10.
We will be 10:30. Okay, I'm back. Now we quickly conclude that the effect of short-term and long-term memory is important in design of interfaces, and gave some examples. And one classical definition is the difference between recall and recognition. So recall is that things you remember. It is the knowledge in the head to be remembered in order to use something. For example, typing a command, typing a code, typing 10, hitting 5. So you should know that you need to be trained that you need to push 5, button 5 in case of something. Recognition, on the other hand, is giving you a menu. That menu may be window based or text based. Text based menus like 1, multiply, 2, add, 3, quit. So that is also a menu. But in this case, you realize that you have the 3 options. You don't have to memorize what you have to do. It is given to you, and you are expected to hit a number. This is what we call recognition-based interfaces rather than recall. So recall-based interfaces is like command prompt, like shell, and other things that require memorization. Doesn't have to be window, text-based window. It can be a touch panel too, or window-based, but it may require you to memorize certain things. That means recall-based interfaces. If memorization is not there or minimal, we say it is a recognition-based interfaces. And it could be in multiple forms. And people say, the Donald Norman says, this is knowledge in the world rather than knowledge in the head. When you go to the restaurant, the waiter comes, what would you like to serve? What would you like to have, sir? Like every time. Okay, every time. Unfortunately, you have been going to the same restaurant for years without knowing that their famous piece in their menu. They have a famous item, but you never had it because they never brought you a menu. You keep asking köfte, for example, but they have another special item. You don't know. You haven't seen it. So the question should be, what would you like from the menu, sir? In that case, it will be easier to select from given choices, provided that the menu items are available. If the menu items are not available, for example, you are given with a menu in the restaurant, you spend 10 minutes examining the menu, decided that you are ready to get tavuk shish. the waiter comes back and you said you like to have tavuk shish, and he says they don't have it. So that is unfortunately interesting experience. Therefore, when user interfaces are concerned, unavailable menu items must be grayed out. So if the menu item is unavailable, show the menu item, but gray them so that user will immediately understand that for that kind of situation, for that particular way of interaction, that item is not available at that time. Rather than having user select that menu and giving a message that that menu item is not available that time. So please choose another one. So that is an incorrect response. If the item is not available, then prevent that from being selected from the beginning. So what we say is, unless there is an explicit reason, user interfaces must be based on recognition. There are some certain situations that recall-based interfaces can be used, but in most cases, you should prefer recognition-based interfaces, and that will require putting out selections to the user so that user will recognize and proceed. Examples: having a button for each operation. So if you are looking for a certain operation, then you look for and find what is necessary. So every function is put down and also associated with a menu. Is it good? There are other problems with it, but it is the items are laid out. It's like a big menu. Sometimes you have small number of keys. On the industrial equipment, you may not have a lot of keys. Then you should bring a navigational method so that elements in the menu will be displayed on screen. So you need to have a navigational mechanism developed, even if you have a small number of keys. Even if you have two keys, one key, if you press two keys together, then you are going in a different mode. Then with the one key, you increase the element, with the other key, you select. Having long press, short presses may mean something different. Therefore, you need to develop a way of moving through the menus, even if you have two keys. Even for the one key also, with the multiple way of pushing, you can develop a menu for the user. This is a camera, I think, Logitech, an old one. Again, a navigational camera can be used when the mouse is not available for the interface. If the mouse is not available, you may have arrow keys to shift through, to move through the selections. For understanding, you are shown with this image and you realize, you try to interpret that, and most people will think that there is a sphere here. Because of the Gestalt laws that we have discussed last time. This one, you probably think that there is a snake on the ground. For this one, you probably think that there is a rectangle in the middle. So anything we see is processed in our brain. That process performance and result depends on complexity and previous memory of the scene in our brain. If we have seen it previously, then we can make more judgment. If we haven't seen it before, there is a problem. When the Turks invaded, when the Huns invaded Europe, first European people didn't have horses, and first they thought that there are different kind of animals coming. Upper part is human-like, lower part is four-legged, because they thought it's a single animal. They haven't seen it. They haven't seen horses before. They thought horse and man is a single animal, unique animal. So processing depends on your previous experiences and exposure to the information. Therefore, when you have I couldn't even draw it. There is a Russian letter, something like this, which we are not familiar. We are familiar with this. So processing depends on the familiarity. If you are familiar, then processing is easier. Therefore, familiar interfaces, familiar use of familiar objects in the interfaces is easier to process, such as the trash can in the interface or eraser is associated with erasing and deleting. Although trash can concept is further deteriorated by Microsoft by calling it as recycle bin. When you say recycle bin, people started thinking that in the recycle bin, someone may be reusing the things that I put there because it will be recycled. Then they started.
Hocam,
yeah.
When you said familiarity, language learning came to my mind, because when I was trying to learn German, I was making connections between English and German, and some of the words were exactly the same meaning. But on the other hand, there were some other words with same writing styles, same letters, but with something entirely different meaning. So even when you were trying to use that word, the English came to mind first. So you couldn't differentiate what that means. So familiarity might sometimes mean something bad.
Yeah, that is what we call interference. That's what we call interference. If the old information is not consistent with the new information, interference occurs. If they are consistent, the neuron weight is increased. Otherwise, it is decreased. Same happens when you are training neural network or deep learning. If you have contradicting input for the training set, then your deep neural network cannot learn because there is no meaningful information to be learned because they all contradict. They're all different. This is one language example, as you said. For a Chinese person, lower letter is easier, maybe than upper letter. But for Latin alphabet speaking people, upper one is much easier to understand. When we are familiar with certain objects, processing time is fast, processing effort is low, so interface will be used with easier manner. When we are processing interface or any kind of object that we are familiar with or not familiar with, the parts are stored in neurons. It is not like they are stored in a JPEG file. When you are storing JPEG file in a computer, everything is stored. But in human brain, important parts are recognized and certain neuron weights are flashed so that that information is taken in. And when you remember, you don't remember the picture of this is the picture, JPEG. You don't remember the picture of the house. Rather, you remember certain bits with different weights. At the end, you say that, okay, it was the house. And you remember the house that you have seen in your childhood, in the very early years, even if you see now. So immediately you can recognize it, whether it is the same or not, whether it is similar to a house that you are familiar with. But it is not like remembering the JPEG image. You don't remember whether they have an electric line coming into the house, or a TV antenna, or how many chimneys they had. When you are asked how many chimneys they had, you don't remember. So it is unlike remembering the picture. On the other hand, when you are dealing with a user interface in a computer, you remember the interface. For example, if it's a spreadsheet application, Excel, or Microsoft Word, or any kind of spreadsheet, or word processor, or web browser, or database application, or student registration application, or banking application, electronic banking application, mobile application, you are familiar with the interface through similar products, or you have used it before. Do you know everything? No, but you remember the interface at some percent, sometimes incorrect, so that you can find your way in the interface. So remembering is not complete. Learning is not complete. Some parts are known, Other parts are filled with the help of the other known parts. But learning is supported, and retention is supported with the number of unique elements and the scene. For example, we are like 40 people here. The human face. How many different muscles we have in the human face? Over 50. More than 50 different muscles are available in the human face. So there are a lot of variables that makes our smile and dislike, etc., and wink very different face shapes and very different face variables. Some people have different noses and eyebrows, etc. Therefore, we remember people. I have Muhammad and Ümmü Seleme's picture here. Other students don't have pictures or avatars. So I remember them when I see them again. And since there are a lot of variables, in the face, it becomes relatively easy for human brain to remember a person or recognize a person when you see them again, because you have seen him or her before. Therefore, we must have multiple cues, a lot of different things visible in the interface, so that processing and recognizing will be easier and powerful. The word easy is taken sometimes unprofessional. Some people may say, doesn't have to be easy, but easy is powerful. So powerful interfaces are also easy interfaces, provided that effectiveness is the same. So if the same similar functions are available in two different interfaces, easy one is more powerful. When you don't give much clues for processing the scene, it becomes difficult to remember. When we are first doing our military duties in year 2000, after graduation from PhD, it was after Izmit earthquake. We went to military base, and for 2 days we were staying with our regular clothes, like we had t-shirt and the pant, etc. We have face, and we made some friends. We go to lunch together, we go to çay ocağı together, etc. We talk to each other in groups. Suddenly, on the third day, They distributed our clothes, camouflage clothes. Then what happened? We couldn't find each other. That's true. Because the clues are gone. Then after another 7 days or 10 days, we learned how to recognize people by more focusing on their faces. Then after 7 or 10 days, there were no problems. We were finding each other by concentrating, by giving our attention to other parts of the body. But the previous one, in the previous times, the person was already recorded with the previous parameters in the brain. So if those parameters are taken out, because the camouflage was given, we couldn't process the scene. We couldn't find the person. Later, after 20 days, there was a çarşı izni. Then we dressed with the normal dresses. What happened? We couldn't find each other again because we forget how to process external stimulus, the clothing stimulus, and the clothing stimulus was interfering with the face recognition. So we had a lot of difficulty finding each other with the regular clothes. So that was an interesting anecdote for human brain to process available information and comparing with the available information in the brain that is recorded previously. That's basically a learning process. If it is learned, then using the interface is much easier. And if it doesn't contradict with the other interfaces. We are different people. We forget. We make mistakes. Our learning process is guided by previous knowledge, and we have different individuals in different abilities and working styles. And interestingly, we don't want to be stupid against the machine. We have different attention and motivation reasons. Some of them are related to payment, daily work. Some of them are for leisure. So different motivation levels are present. And we want to be the boss. We have to be the boss, not the machine. We don't want getting directives from the machine or objects. We want them to obey us. We want them to be tools rather than masters. We want them to be slaves rather than masters. So that is quite important. If the system is trying to dictate something to you, then users usually get away from that kind of interaction. They don't want to use it. So be careful what you are saying to user during the interaction. If you talk from the upper sense, like if you are trying to direct user, telling him to do this, do this, do this, do this, it is very irritating, and after a while people don't use it. So you should say please, would you, etc. Always use please, can you, etc. That's interesting topic. Here we see a user interface laboratory, a traditional user interface laboratory. In the traditional user interface laboratory, we have one-way mirror. One-way mirror was a significant part of the user interface laboratories because researchers wanted to observe user in a certain private environment, relatively private environment. Because if somebody is watching you directly, you cannot work. So that way there is a recording going on, cameras. One camera is recording screen, another camera is recording the user, etc. And these are also watching the experiment and trying to understand what is happening. Let's say half of the research done in human-computer interaction is based on testing and experiments. Since we are dealing with human, there is no analytic solution for many problems. There are reasoning issues, but analytical solution is usually not possible. Therefore, to understand many things, we do experiments. And based on the results of the experiments, we try to derive certain rules and principles. These principles are important because they are valid most of the time, unless there is a reason. And when these principles are followed, usually good interfaces, successful interfaces are developed. But for new kind of interactions, performance of new interfaces and new techniques, we do user testing. If you have two different alternatives and you are trying to understand which one is better, it is in the industry, it is called as A/B testing. Is it either A or B? So A is tested, B is tested, performance is measured. Which one is easier? Which one is more difficult? Which one is more powerful? That's what we call A/B testing. And there are other types of testings as well. When the person is exposed to an interface, real-world experiences affect the mental image. As we learn, we look for patterns to predict future outcomes. Because our life is based on prediction. I have this. There is some tea, probably cold. So my prediction is if I drink it, I can finish it with a certain movement. So I adjust and I set my goals based on the things that I get to my brain. So I observe, I look for patterns, I match those patterns to my previous knowledge, I decide and act. So sometimes it is superstitious, sometimes it is incorrect, but sometimes correct. So the below interface, for example, and on the right side, you have an MP3 player or CD player. There are buttons. Some buttons are play buttons. Some button is eject button, etc. So they are analogous to a CD player. There one of them is volume. Another one of them is balance, left, right. Which one is volume? Which one is balance? Obviously, the one on the right is balance because it is smaller and it is at the center at the beginning. How do I know it? Because of the previous experiences. My previous experiences are exploited and used, which is good. That's what we call mental model. Mental model of a device is formed largely by interpreting its perceived actions and visible structure. So we observe it. It looks like a mouse. So if it's a mouse, there is an orientation, forward and backward. This is wireless. So it is mainly formed by visible and also by its actions of the structure. It could be on the screen, it could be a real life object, same. So by understanding these mental models, we can predict user behavior, we can explain user behavior, and we should keep in mind that the mental model of each person is not the same. There are different mental models. One of the interesting mental models is a wheel of the car. If you turn the wheel to the right, car goes to the right. If you turn wheel to the left, car goes to the left. So left, right is mapped onto behavior of the vehicle. Your mental model says, in order to go to the right, you need to turn to the right. Fine. No problem. I'm happy with it. But if you are in a boat, and this is the boat's rudder. In Turkish it is yeke. In English it's rudder. Then in order to go to the right, you need to push to the left. Efendim. Dersteyim. Tamam, bye bye. So the mental model of this user, if the person has no previous experience with a boat control, he or she may have trouble at the beginning. But if you show the structure with more open explanation, if he sees the structure here, he may understand the mechanism of the work, and then the learning might be relatively easier. So behavior of the person depends on how visible the interface is, how open the interface is, what are the variables that are exposed to the person. So they are all dependent to each other. We have a famous example here. I put this example based on the Donald Norman's book, but it's not from the book. It is kind of something in between. So we have a model about a refrigerator. This is what a Vestel refrigerator, a Turkish brand refrigerator is set up. There is a setup for the refrigerator part. There is a setup for the freezer part. So obviously this part is for left part is for freezer, right part is for refrigerator part, fresh food. Each of them, there is a clock here. There is a cooler setup. There is a freezer setup here. So by pressing these, you increase the level of cooling here. By pressing freezer, you increase level of cooling here. Okay. Based on this interface, what people think is, no, this is another brand, Beko. In this one, outside, you have this interface. Inside of the freezer here, there is another interface which you rotate with your finger. 1 is the minimum, 10 is the maximum, so you adjust it. 3 is normal. So based on these two interfaces, in the first example, in the Vestel one, you tend to think that there are two separate units. You tend to think that there are two separate units. One of them is freezer, one of them is fresh food, and there is a control on the left, there is a control on the right. Each of them is connected to different thermostats, and different compressors. So this is what you think. So you start to think like there are two different systems there, and separately that can be separately controlled. That's how your understanding based on the interface, and you tend to act based on that and understanding. In the Beko interface, this is more like what you expect. There is a freezer and fresh food compartment, and this one, the control inside the freezer from 1 to 10 is basically controlling this valve, air valve, mechanically, and thermostat is controlled by control A, which is the general temperature of the refrigerator, and therefore there is only one cooling compressor, which is more logical for a daily refrigerator. In this case, this one is quite misleading the user than this one. So several questions, several usage scenarios, incorrect scenarios can be faced. I want to leave the things in the freezer frozen, but the fresh food section is empty. Can I turn it off? So if you are not using the freezer, can you turn it off? You may think that in the Vestel case, in Arçelik and Beko, you can't, because interface says they are connected, but Vestel says they are disconnected. So this question can be asked, and some users may try it with the Vestel. Second idea is, I'm not using freezer. Maybe I can use freezer as a fresh food compartment after increasing the freezer temperature above 0. So since they are separate things, can I use it differently? The answer might be yes. But in many refrigerators, the answer is no. However, new technology new refrigerators, new freezers do that. So there are some brands of equipment that allows the freezer part to be used as a regular refrigerator. If you don't need freezer, you can switch that to regular refrigerator. So improper mental models, that's what I'm trying to say. Improper mental models will often result in unexpected problematic uses. Sometimes people will say, bilgisayar kafayı yedi. What is that, bilgisayar kafayı yedi? In many cases, bilgisayar is acting correctly, but it is behaving different than what you expect. In that case, the model that computer is following deviated from what you think, then you say that bilgisayar is not working, computer is not working correctly. Therefore, we need to follow, we need to understand mental models of the users. So as a designers and engineers, we need to understand mental models, and we need to create correct mental models. If we don't create correct models, users will make mistakes, and we don't want those mistakes. One example is, this is an automated white screen. This is the switch for up and down. This is the switch for light. A similar example that I was giving as bell and the door. So in this kind of classes, many errors happen because most people believe that the switch closest to the white screen that controls the white screen. Switch farther away controls the light. If they are connected vice versa, users will follow the way they think based on what I said. So there will be mistakes. And those mistakes are not user mistakes. Those mistakes are then designer mistakes, engineering mistakes. Don't blame the user for pushing the incorrect button. This is an early type of tape recorder. The play was P, forward was this, backward was this. So forward and backward was iconic, but the play and stop was not during the beginning. So over time, over the industrial progress, people are trying to develop mental models based on the many things that we see in the surrounding. So this arrow is now today associated with play. Continue. When you have this, usually associated with, if you press 1, that means play. If you press again, that means pause. Pause and play on the same button. That's how we learn. And important things are labeled with the color. So this is record. Since record is erasing certain things, it is important. So erasing existing information in the tape. Therefore, it is red. They all learned through the years. So CD player and buttons. Next to tape player, there are CD controls. Next to CD player, there are tape controls. This was the technique in many tape players several years ago, because technically CD player was an add-on to tape players. So in order to add additional CD player to a single tape player, they put the buttons in a technically appropriate place, but not mentally correct place. So many errors happened after this, but fortunately nobody is using CDs anymore today for music recording and music playing. Therefore this thing is gone away. That was now part of the history. When you see something like this, usually you associated it what? Back. Go back. It is a learned fact. So when you need something like a back function, you can use this kind of icon, arrow. That's okay, because that makes you feel that within this menu, I can go back. I can go back to operation by hitting that. So that menu item here, that button is strengthened with your previous experiences. In your previous experiences, that kind of button is associated with back. How about this? Turn on. How do you turn on? Press. No, you press long. You press long so that it turns on, because it's a learned fact. When you see this, it is usually the case with your previous experiences that if you press long enough, it will wake up, or if you press long enough, it will sleep. If you press 30 seconds, it will reset. So those are learned facts. When the interface is incompatible with the mental model of the user, if the mental model results in unexpected outcomes, users develop new mental models based on the results of the interface, such as you click something and some other thing happened than you expect. Then you say, okay, maybe it is behaving this way. And you try again. You try again with the new correction in your brain. If the second model does not provide desired results, user becomes confused, moved into uncertainty, and he or she doesn't know what to do. Sometimes, and usually, it claims that the system is not working. System kafayı yedi, because his mental model or her mental model is not aligned with the model that the system is following. That they are working in the different directions. For an emergency button with a lock. So if you see a keyhole, can you be sure that you can push that during the emergency? How do you know that it is not locked? You don't. So this is kind of dangerous and can be used by special purpose, where locking is very important. Then, based on our previous experiences, a pen is for writing. A cup is for drinking. A button is for pushing. When something needs to be pushed in the interface, there must be a visual cue. That's what we say, cue. İpucu. Visual cue, so that people will understand that it can be clicked. And famous HTML underline blue link is one of that. When you see an underlined blue link, it means there is a link behind it. It can be clicked. You don't have to go over it in order to understand that it's a clickable image, it's a clickable link. It is already saying that please click me. If the link is purple, it says you have been there before. So it's a very good way of doing hyperlinks. And please, whenever possible, follow this convention rather than using these colors and underlining for other purposes, other cosmetic purposes. Unfortunately, today some design choices rely only on going over something in order to understand that they are links, which is very incorrect. If something is a link, then it has to say itself before going over to it. If you have watched Donald Norman video, he was talking about the doors in England. So usually if the door handle is vertical, it means pull, because you can pull it. You can hold it and pull it. If the door handle is horizontal, or there is no handle, if there is no handle, let's push. Just a plate and push. That's very interesting. Otherwise, people are having difficulty. For example, turn right or turn left. How are you going to open it? You should be able to tell what to do just by looking. How about these? Turn on and off. So these are buttons. How do we know that these are buttons and these have two different places to push? Because of the raised appearance, because of the appearance of the buttons, we understand that they are clickable. And that's what we call affordance. Affordances in user interfaces. In user interfaces, affordance means please click me, please use me this way. So telling something by appearance, by behavior, so that the object is used in a correct way. Second thing is the mapping. Most student houses have these kind of vertical. Most houses have those kind of, or front, for some of them are front. If you have an older one, front. So you cannot tell which one is which. There are marks. Do you understand? Probably yes. But if you are living in a student house, this place is probably too dirty so that you cannot see it from the oil. And every time you try to turn on the gas heater, you fail. So the correct way is to, this is an example of course, correct way is to use this kind of arrangement. Technically it is more costly, but there is no issue about mixing which one is which, and there is no need to put visual instructions. Okay. This is what we call mapping. For example, if you hold and increase a lever with holding the mouse and moving it up, the value should be increased, not decreased. So it is correct mapping. Going to the right is also meaning increasing. Turning to the right, increasing. Turning to the left, decreasing. The one on the right controls the one on the right. This is what we call mapping in the user interfaces. Correct mapping. Incorrect mapping will result in incorrect use. One interesting example. This is from an early type of Mercedes car with controlled seats. These are movable. If you want to control seats, just hold it and move associated parts. So it is correct mapping. There is no confusion. There is no selection from the menus. Just hold it and move it. And these are the memories for different drivers. For the calendar, coming days, previous days, just like the regular calendar. Increase the value, decrease the value, increase the value, decrease the value. Okay. These are examples of good mapping. A question. The dog is facing west. Make him face east by changing the positions of just 2 matches. The answer is not moving these here and moving tails here, so that doesn't work. The answer is this. So usually what assumptions are making things hard. If you have an assumption, pre-assumption about user interface, and that pre-assumption is incorrect, that is due to the mental model, it is not, I wouldn't say incorrect, but that is different from the interface, then you fail. So habits and acquired skills can sometimes prevent creative actions. So there are different ways of behaving, and habits and skills prevent that kind of actions. That's not a negative issue. It's only for our understanding because we are going to design the user interface. And therefore, we don't always know how user thinks. We want to solve problems. User want to work. People want things done. In order to get things done, you need to represent the problem. If the problem is represented poorly, user will have difficulty solving the problem or completely fail. This problem is daily problems or computer tasks, but also true for the exams. If the exam question is represented poorly, probably many students will fail, cannot solve it. Even if the question is easy, the question is represented incorrectly, represented poorly. I wouldn't say incorrect, but poorly. Poorly is the best word for it. If the problem is represented poorly, then many people